Welcome, or hopefully welcome back to the Reliability Matters podcast. For those of you who are counting, this is episode number 151. 2 episodes ago, on episode number 149, we talked all about automated optical inspection. Today, we're exploring the impact of less automated inspection technology, that being optical microscopes. From commercial Class 1 electronics to high-reliability Class 3 electronics, the intricate electronic devices we rely on daily are assembled with astonishing precision. This precision wouldn't be possible without the aid of advanced optical microscopes. These remarkable instruments allow technicians and engineers to inspect, analyze, and ensure the quality of electronic components, down to the minutest detail. On this episode, we'll uncover how optical microscopes have impacted electronic assembly, enhancing productivity, ensuring reliability, and driving innovation. One of the unique benefits microscopes provide, particularly in hand soldering applications, is the ability to view and solder the assembly under high magnification through the microscope. Obviously, this is not something any AOI system can perform. But microscopes are not limited to soldering applications. One of the most critical applications of optical microscopes in the electronic assembly industry is the inspection of circuit assemblies for quality assurance. Circuit assemblies are the heart of many products, comprising numerous, highly miniaturized components and connections that must be flawlessly integrated. Even the smallest defects, such as a microscopic crack or an improperly soldered joint, can lead to significant malfunctions or failures. Optical microscopes enable detailed inspection of these assemblies, allowing quality control professionals to identify and rectify issues that would otherwise be invisible to the naked eye. By providing high-resolution images and magnification, these microscopes help in detecting defects, ensuring correct alignment and polarity of components, and verifying the integrity of solder joints. This meticulous inspection process is crucial for maintaining the reliability and performance of electronic devices, ultimately ensuring customer satisfaction and, in many cases, safety. We'll hear from 2 industry experts who will share insights on the latest technological advancements and how these tools are indispensable in maintaining the high standards of modern electronics. Neely Walp is marketing manager at Vision Engineering, a manufacturer of microscopes designed for various industries, including the electronic assembly industry, where she has worked for over 8 years. Neely earned a bachelor's in communications from Boston University. Richard Nagel is vice president of sales and marketing at Vision Engineering, where he's worked there for over 21 years. Richard and Neely will share insights on the latest technological advancements and how these tools are indispensable in maintaining the high standards of modern electronics. And we'll cover all that when I return in just a moment.
Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Conrad.
Neely, Richard, thanks for being my guests today.
Thank you for having us, Mike.
Well, I'm glad you're here. We've covered many topics on this show, including inspection, but for some reason, we've just flown over microscopes, and we've talked about automated optical inspection, SPI, X-ray, all sorts of things. But for whatever reason, we've missed a really important topic, and even companies with very expensive AOI, SPI, X-ray type of equipment still have microscopes. Lots of them all over the assembly areas and inspection areas. So I want to talk about that. But before we do, give me some background on Vision Engineering. You both are from Vision Engineering. Vision Engineering obviously manufactures microscopes for various industries. Tell me a little bit about the history of Vision Engineering, where you are in the world in terms of the markets that you serve, and loosely speaking, the types of products that you offer.
Sure. Well, let's see. Vision Engineering was founded over 60 years ago by Rob Freeman, who started out as a racing mechanic for the Jaguar team located in the UK. And while there, he developed a Boroscope that was used for inspecting the race car engines. And it didn't, the Boroscope enabled the inspection to happen so that the engines didn't need to come apart. And that was really the start of Rob's love for optical inspection. In 94, he started vision engineering and launched the Mantis, which was the world's, well, is the world, sorry, can we start again?
Of course. Start wherever you want, no problem.
Okay. Okay. Sure. So vision engineering was founded in 1958 by Rob Freeman. Rob started as a racing mechanic for the Jaguar racing team in the UK, where he developed a boroscope for inspecting internal race engine parts without the need for disassembly. Vision engineering started as a specialist contractor for large British companies like Rolls-Royce, and this really served as a means for Rob to develop his interest in optics as it applies to the manufacturing industry. In 1994, Vision made its mark in the electronics world, in the microscopy world, by the introduction of Mantis. And Mantis is the world's first eyepieceless microscope. It soon became the benchmark for ergonomic stereo magnification. And then over the years, vision engineering, we've developed optical and digital inspection systems with patented technologies. And we now have a range of measurement systems as well. And they're all designed to improve quality for companies with the heart of ergonomics behind each system. Our systems are used globally in electronics, medical device, automotive, aerospace, and pretty much any application where a microscope would be needed.
Yeah, I can imagine that's a lot of different industries. You guys have to go to a lot of trade shows and write a lot of technical articles for a number of different journals, all of which the content is probably similar. The context of that content varies from industry to industry, right?
Yes.
But still,
it's just the application, really.
Yes, yeah.
Exactly. I mean, you make small things big, right? So going back to Rob Freeman, he's holding the Boroscope. So a Boroscope is a optical device that can go down a hole, basically, or penetrate, right? It's got a flexible connector and either a camera at the end with a connector or some kind of reflectors and things like that. And did he invent the Boroscope, or did he come up with one that was specifically for automotive?
No, I don't believe Rob was the inventor of Boroscopes, but he came up with something that was specific for the application at the time.
Right.
Rob being the sort of person he was, the idea of having to strip down a racing car engine just to have a look at, see what wear and tear had taken place, didn't make much sense. Hence he came up with this idea, and I believe he actually made the first one with a pair of binoculars that he had found and bought at a pharmacy. That was Rob. Whatever was available, he could make something work.
We would equate him to maybe an early MacGyver, right? He was able to.
Right.
When I first started my company 32 years ago, it was a startup out of a garage, so we didn't have big budgets and we didn't have lots of resources. So I basically walked the aisles of Home Depot and went through the Grainger catalog, and I figured, okay, we're going to design a product where every part I can buy, I can get at either Home Depot or Grainger, right? And it wasn't like what would be the best part for the application. It was more like what would be the best part that I have access to. And this is before the internet, right? So there was, you had a few choices. You had Thomas Registers, you had Grainger, and you had hardware stores, Ace Hardware, Home Depot, you name it. Electronic stores, things like that. But it was basically retail purchasing for a wholesale product, which is not a great business move, by the way. But I do really appreciate the ingenuity. And I love when company founders have unique stories like that. They had a need. It's not like he grew up wanting to invent a boroscope for that. He had a need. He was working on cars, racing cars, didn't want to spend the money tearing apart an engine, pulling a head off, just to just to see if the valves are clean, it might as well just send something down there. And I think since then, the plumbing industry and so many other industries have used that technology for the same reasons, right?
That's right.
So here's probably the easiest question you're going to be asked today, and probably all week, maybe even all year. Can you explain the role of microscopes and other visual inspection tools in the assembly industry for circuit assemblies? What various roles do they play? There's an obvious role, and then there's probably some less obvious roles that I'm not thinking of. What are the numerous roles that they play?
Well, Mike, as you said, magnification is becoming more and more important. Components are getting smaller; they're being miniaturized. Circuitry is being miniaturized. So magnification has become more and more important in the electronics PCB manufacturing and assembly thereof. I think things like looking at cold solder joints, bridging, insufficient solder, thinking of SMTs now, where components are getting a lot smaller. So placement of SMT components on boards, etc., again, become very, very important. Magnification, that is. But something we should also look at is microscopes have moved on from the normal stereo microscope, which is something that is used allowing the inspection of solder joints, formation or proper formation of solder, cold solder joints, bridging, insufficient solder, and rework of PCBs and components. Something that's coming in more recent years, though, is the digital microscope, which is now also found a place in PCB manufacturing. Something where we have to draw the line and determine which is the better tool is really stereo microscopes are essentially where you need depth perception, whereas a digital microscope's a 2D image. So there's a tool for each application. If it's just pure inspection, digital microscopes are the preferred tool. However, if it's for rework, then obviously a stereo microscope is the tool of preference.
Yeah, that definitely makes sense. Depth perception, field of vision, field of view is obviously really important. A 2D image can't see certain things that you could see like polarity, and you could see maybe part of a solder joint failure, but you really don't see the full picture unless you have more of a 3D effect, which you really need stereo to do. When I think of microscopes, the first thing that comes to mind brings me back to the 1970s when I was in high school, and I think we all had experience with a microscope that looked like this. For those of my listening audience, I'm showing a picture of a high school microscope from the 70s. It's this very heavy, weighted tool that was extremely mechanical. It had two portals that you aligned with your eyes. You had to adjust the width apart from each other so that they would match your eyes. It had a knob to bring it into focus, and each of the eyepieces also had a little bit of an adjustment. So it was quite an art form to look through that and bring everything you wanted to see into focus. And depth of view was frequently, particularly in high magnification, adjustable, meaning that if you wanted to see the bottom of something, the top of it was out of focus. If you wanted to see the top of something, the bottom of it was out of focus.
Correct.
And you really had to massage the microscope to see anything. A lot has changed obviously a lot. I'm preaching to the choir here, but a lot has changed in the microscope world since those things were on our lab tables. To me, the stereotypical view of microscopes just seem a little clumsy. I know those who work with them every day, it becomes like an extension of their hands, in their eyes. They know how to work it. But to mere mortals like me, they've always been very clumsy. I've never really enjoyed looking through a traditional microscope. what are some of the most significant advances that have been made in the technology of microscopes that are advantageous for the inspection of circuit assemblies?
Mike, I think one of the most recent introductions, and I say recent, it's been around for quite a few years now, but the biggest change and game changer in microscopy has really been the introduction of eyepieceless microscopes. This really gets around the issue where people had, like you alluded to earlier, having to look down two eyepieces, or like looking through a pair of binoculars and trying to acquire one field of view. And some people are challenged doing that. Whereas eyepieceless microscopes gets around that issue. You no longer have to look down these two very small eyepieces in order to acquire an image. So that's,
and Richard, describe for my listening audience who don't have the benefit of watching this on YouTube, describe what the product that I'm showing on the screen right now, which is not a traditional two-piece optical microscope.
Right. So basically what is, in this particular instance, it's a product that was launched by Vision Engineering. It's an eyepieceless microscope. So what you essentially have is an optical screen. People look down and think it's a digital image, but it's not. It's a pure optics. So you have like a normal microscope, you'll have lenses at the bottom of the microscope, which you can then choose the magnification required. And the image is then projected up optically onto the screen, and it's extended out. So when I say screen, it appears to be a screen, but it's not. It's an optical image that you actually see. But it's also extended beyond where a normal microscope has a fixed exit pupil distance, which is normally very, very close to the eyepiece lens. This extends out a lot further. By extending that out, it means the operator can sit in a very neutral position where they're back straight and not having to lean forward and look through eyepieces. So essentially, without having an image in front of you, if you could think of a small screen that you're looking at, that's part of a microscope, but all built into the instrument as such. I think that's the easiest way to try and explain it. For my
geeky audience like me, those of us that grew up with Star Trek have a vivid memory of Spock looking into something on the bridge. He put his face into something that looks remarkably like that, where it was some kind of sensor or some kind of monitor, and he would look into it. That's what this reminds me of. It's easy to look at. It's from what you mentioned, I hadn't really thought of that. Has a lot more ergonomic sense to it, because I just can't imagine leaning over a traditional microscope for 8 hours a day. There's no way to make a traditional microscope like perfectly ergonomic, because you have to kind of be over something looking down at it, and it's hard to kind of protect your back and other things with that. This brings the image to you more toward a human face than a traditional optical microscope would do.
Sure, whereas a traditional microscope, the spine's curved, so there's a lot of stress that's put on the neck, the back. There's chances of repetitive strain injury, etc. So this is exactly what Neely mentioned about the ergonomics and Rob Freeman really looking at things from the outside in as such, and realize that these were some of the big challenges microscopists or operators had to face. Hence the introduction of the eyepieceless microscope. So the closest thing to that, which, and that's where a lot of confusion, or where there's a lot of confusion, should I say, is people think, well, the way out is to use the digital microscope, because then you look at a monitor. The bigger problem is, though, it's a two-dimensional image. And it's exceptionally difficult to, say, do rework on small components, because there is no depth perception as such. So how do you really try and do rework where you don't know exactly where the soldering iron tip is, short of having to touch the component and say, I'm about there. And this is where there is confusion, because people think, well, that's more ergonomic, I can sit back. But the challenge is to try and use it then for something like rework on a board or placement of components, etc.
Yeah. I would assume the technology behind an eyepieceless stereo microscope is similar similar in nature to the old viewfinder toys we had when we were kids. Remember, we had the
Yes.
slides, the little round disc, and we
Correct.
dropped it in and
Right.
pulled it, pulled a shutter
That's
and
right.
it advanced to the next image.
And rotate it. Yeah.
What was amazing is, we held it up to our eyes and we were seeing a stereo image. We had some
Correct.
depth of field. And
Sure.
I would imagine the tech is, a high-tech version of two images coming up to one piece of glass that the human brain perceives as three-dimensional. It's probably a very expensive viewfinder. Not to but instead of looking at a predetermined image, that was photographed by some photographer somewhere and stuck on a slide, you're seeing live images of real product. That's interesting. Are there capabilities that an eyepiece-less microscope lacks that a traditional, dual lens eyepiece microscope can provide? Are there some limitations? Because I would think there needs to be some, because otherwise, why would anyone opt to lean over a microscope and align their eyes when they can just look at something, that's A, more ergonomic, and B, just as effective? So what are, if any, what are the limitations of that, and what would cause someone to go toward one tech versus another type of tech?
Well, I think there's two reasons. There is a limit in this particular application, or this particular unit. There's a limit in magnification. However, we do have a stereo zoom instrument, which is also eyepiece-less, where the concept very much the same, where you're looking at a digital image, a screen, but it's a piece of glass as such. And that takes you to higher magnifications. I think where there is a limitation is the number of accessories that are available. However, in the electronics industry, we address most of the issues that are available on a normal eyepiece microscope with our eyepiece-less technology. With it, as I said, we can offer a zoom instrument. We can offer accessories which allow you to rotate around an individual component optically without moving the PCB. You can rotate around this optically, which is available on normal eyepiece microscopes. Only some there, to be honest. But we have that technology. You can do photography with either of the systems, in other words, capture images. You can do measurement. So there's very few applications which we couldn't address by using this technology. And off the top of my head, I really can't think of any in the electronics industry.
Right. But the main limitation is the extent of magnification. I mean, you're not going to compete with an electron microscope, obviously.
Exactly.
No optical one would. But traditional microscopes have a potentially a greater magnification level than an eyepiece-less microscope would in general. Maybe not enough to make a difference in this world, but that would be one of the limitations. Right.
Yeah. So in this world, if we talk about electronics and PCB, we can address all of those magnification needs. But if you start going to higher magnification, say wafer fab, etc., yes, then the magnifications required are far larger.
Sure. So Neely, what are the different? Educate me, because I'm clueless when it comes to microscopes. Or at least the detail of microscopes. What are the different types of microscopes? We talk about eyepiece microscopes and eyepiece-less microscopes, but within those two worlds, what are the different? How do you categorize microscopes, and are there different types of microscopes for different types of applications?
That is a really great question, and I think Richard would be better suited to answer this particular question. I could give you the names of the microscopes. There's inverted microscopes, there's compound microscopes, there's runoff microscopes, but how each one is different, I think Richard has much more experience.
That's a great job of catching the ball and throwing it out to left field. Richard, catch the ball.
Right. Yes, so the main microscopes, really, if you look at light microscopes, if we exclude all of the likes of electron microscopes, and even in electron microscopes, there's transmission electron microscopes and scanning electron microscopes. But if you look at the optical microscopes, there are stereo microscopes. Then there's upright compound microscopes, which is a traditional microscope that you might say you'd find in a laboratory looking at thin sections of anatomy, smears, etc. Then you get inverted microscopes. The big thing right now in inverted microscopes is cell culture, which is used artificial insemination. Inverted microscopes are used for, and then of course, as I said, you've got different types of illumination that is utilized on microscopes. But again, out of our world of electronics, really in the biological sciences, whether it be microscopes with different types of illumination techniques, Namarsky interference, fluorescence, for instance, which is really not in the realms of the electronics industry.
Right. I would imagine with electronics, it's just more about clarity and magnification and ergonomics. I would think. Hopefully, we're not doing any artificial insemination within the electronic assembly industry, and
what much? Yeah,
at least not intentionally. And
Sure.
So the need for inverted microscopes is probably not
at all
well existent in our world.
Sure.
So what are the ranges of within the electronic assembly industry? What are the choices a customer has to make? Do they choose max magnification? Do they choose depth of field? Do they choose, lighting? What would drive someone toward? Let me back up a little bit. When I go on your company's website, you offer a multitude of products, all inspection products, all microscope type products. What would be the criteria that someone would use to choose one of your products, or anyone's products for that matter, over another product within the same catalog?
Sure. So I think the important things to really, the user has to really ask himself is, first of all, the magnification range. I mean, that is one of the biggest deciding factors, is what magnification do I really require for my application? That narrows it down to a certain extent. Do I just need a fixed magnification, or do I need zoom, depending on, again, the application? Do they go from very small components to larger components? Again, am I going to work under the microscope, or is it just going to be for inspection? And then again, do I need to capture images? Do I need to capture it for quality control purposes? Do I need to possibly mark up a photograph where I'm going to include it in a report? Or is it you might be in a situation where you do work for a third-party company. You need to report back to them with findings of, say, an irregularity of a component. And then things like, how important is field of view to you? That again determines the sort of microscope you need. Some people need to say, get a 8 by 8 inch PCB as a one captured image. That's pretty challenging on a normal microscope, but you can do it with certain digital instruments that are out in the marketplace. But over and above all of that is really depth of field, working distance, and resolution. Those are three vital things you really got to, besides the magnification. Is, you can have the greatest magnification in the world, but if it's unable to resolve the subject, it's pointless having. It's what we termed as a vacant magnification. In other words, you don't see any detail. And contrast's obviously very important as well.
And we've talked a lot on the show about AOI, as I alluded to earlier.
Mm-hmm.
And clearly you can't solder a connector onto a board using an AOI machine as the basis for your image. I mean, they take pictures, right? They take momentary pictures very quickly. And with AI and all the algorithms, they can spot defects, better than anything in terms of speed and accuracy. But there's certain things that microscopes can do, even in an inspection context, where AOI is all for inspection. Microscopes are also for inspection, using humans to discern what the image they see on the screen is telling them. But are there things that microscopes, from an inspection standpoint, with an operator, can just do better than a traditional AOI technology? Maybe AOI has gotten so good there's nothing that microscopes and a good, well-trained operator can do better. But I would assume there probably still is. Humans are, filled with intuition and gut and experience, and
Sure.
AI is always catching up to that. But is there something that just, at the end of the day, you just can't beat a good old-fashioned microscope and a well-trained human?
Of course. I mean, there will be applications where humans need to do the inspection. For example, prototyping. Designers will come up with something, but maybe a program hasn't been written for AI, so they will need to resort to microscopes and the inspection tools that they have on hand, and their experience, and their gut, and just being human for that. But even in an AI world, you will still require human interaction, because there should be spot checks of what's going on. You can't solely rely on an algorithm or a robot or computer program to do the job. Humans, I hope they haven't written us off just yet, but we still need to be able to spot check to make sure that products are being inspected as per the procedures in place, and that there's continuity and consistency in the line.
Yeah, I would think rework and repair also falls into that category, because you can't
Exactly.
program an AOI machine to inspect rework, particularly before and after, because who's going to write an
Exactly.
algorithm for every possible combination of rework, right?
Exactly.
Yep.
That goes without saying. Yes. Yeah.
Yeah. And then I guess one of the other advantages is price. I would imagine the most expensive microscope you sell is sales tax on an AOI machine, right? It's
Possibly. But as we keep going back, there's nothing better than the human brain right now, as far as spotting faults, identifying the faults, better said. And as you correctly pointed out, to find that fault and then actually do the rework, AI hasn't got there yet. And I think it's a long way off.
Sure. And, AOI only knows what humans know. It
Correct.
it basically
They get
scours
taught, exactly.
the annals of publications written by
Sure.
humans. And it will learn always just slightly. It will always, by nature, be slightly behind. Now, there's generative AI, which AI learns from AI, which gets a little scary to think about. But then again, humans learn from humans too, so we're
Correct.
somewhat generative as well. What are some of the common challenges faced during the visual inspection of circuit assemblies? What are common challenges, and how can those challenges be overcome?
I think some of the most common challenges with microscopes have really been magnification and depth of field, because the two really work hand in hand, because the higher the magnification goes, the less the depth of field. And unfortunately, a lot of operators feel bigger's better, but in some instances that isn't the case. So I think meeting that happy medium of magnification versus depth of field and field of view, of course, are some of the larger challenges that are faced in microscopy.
So in your world, you guys...
I would also add
sorry, Neely.
light. I would also add illumination to that. Having the right illumination to see all of the details in the subject. That needs to be
Correct.
Accurate.
Yeah, I'm constantly pulling out this side of my phone and turning on the flashlight
Especially in a restaurant.
In a restaurant, it's funny because things are clearer. I can't read. I have to wear my little cheap readers when I'm reading a menu or something. But if I just light it up, then suddenly my vision improves. Right? I can maybe get by without my readers if I just put a little light on it. I would imagine illumination in this world for inspection is really important because you don't know if you're looking at a shadow or if you're looking at a solder blob, right? They kind of look the same under those conditions. And I would imagine there's quite a bit of technology for illumination. I mean, it used to be little incandescent bulbs, and now they're LED ring lights and all these different things. And the angle that the illumination emanates from or hits the target at it also plays games with shadows and things like that. So you really have to flood the target with the right type of light, right? And I would imagine, Richard, you alluded to in other worlds and other applications, the type of light, the type of illumination is crucial. Maybe black light in some cases, UV light or whatever.
Right.
Sure. But Mike, as far as the ring light's concerned, again, I'm glad you brought that up because there are some manufacturers that manufacture a ring light which has quadrants. So we offer a ring light where you can actually turn quadrants on and off. So if you look at a normal ring light, that produces 360 degrees worth of illumination around a subject, which is ideal for the normal application. But if you wanted to look at a surface finish, for instance, or anything that has surface texture, if you flood it with light from 360 degrees, you don't pick that texture up. If you turn off a quadrant, you're then getting light sharing through from one side, causing a shadow, which then highlights relief on a flat subject or a surface with this function to it. So,
I guess with all solder joints look smooth and shiny if you have enough illumination on it. But if you really want to see how grainy it is, if like a cold solder joint, grainy, kind of sandy look, then that kind of offset illumination would help.
Correct.
Yeah.
Correct.
No,
so you can switch through that through 360 degrees, as I said, turning one quadrant off and the other. So that is an area. And of course, if we have a look at things like UV illumination, which is used in some areas in the electronics industry, we have conformal coating. If you want to see if conformal coating is there, UV illumination is an accessory which is available on our microscopes as such.
Excellent. One of the most, I love to talk about negative reinforcement mistakes because everyone identifies with that. What are the most common mistakes made when selecting a microscope? I'm sure people come to your company all the time and say, I want this. And maybe this is not the best choice for them based upon what they think they're going to be using it for. So what are some of the mistakes that purchasers of microscopes tend to make?
Well, I think one of the biggest in the electronics industry, at least, one of the biggest mistakes is they choose a microscope which, first of all, doesn't have sufficient working distance, which is always an issue. As you know, specifically if you've got to get a soldering iron or tweezers or something underneath the microscope, that is always a challenge. And again, we go back to choosing a stereo over a digital instrument. That can be a very costly mistake. If you invest the money in a digital microscope and then find you can't really use it for rework, or it's very difficult to use for rework. I would say those are two of the areas. And again, as we alluded to, illumination, of course, is also something important. Whether if they choose a ring light over a quadrant ring light, which the application might require, surface features might be important to them. I think that's the other area. And also looking at a microscope that is not modular, because you could start off with a standard microscope, whether it be eyepieceless or have eyepieces, whatever the case is. And if it's not a modular system and suddenly you realize that you want to add a camera to it, or you want to add an illumination,
Yep.
which allows you to rotate around components, for instance, without having to move the PCB around. It's far too late to then have to do that. So I think modular microscopes are always the way to go, because it just leaves that door open for the operator or for the application as things progress. Being able to increase magnification is also quite important in some instances. So as we all know, component sizes are getting smaller and smaller. So if you buy a microscope and then 5 years down the road, if you can buy another lens for it and increase the magnification, it saves the investment of a whole new microscope. So I think there's a couple of the areas, as I said. Most critical is working distance and using the right tool for the job as far as stereo versus digital, and modular. I'd say if you looked at those three, those would really help you moving forward. But those are the more common mistakes when people buy digital over stereo or insufficient working distance. Again, I repeat that because we see it time and time again.
I think some of the answers that you just provided can be carried forward to the next question, but I'll ask the question anyway because there might be some unique answers there. If I'm looking for a microscope, what questions would you ask me to ensure that you can direct me to the proper piece of equipment? Not what questions am I not asking you, but what do you what's the go-to? Say I'm a contract manufacturer in the electronic assembly space. I need 12 microscopes. Go.
Right. So one of my first questions to you would be, is it for inspection or rework? Mm-hmm. Because that'll help.
That helps with the working distance, right? That
That
you
also
talked about
helps
earlier.
with whether it's going to be an optical or a digital system.
Okay. What's better for
So
what specifically between digital and optical relates to rework or inspection?
Well,
So-
if it's for rework, you would be then looking at an optical stereo microscope as opposed to digital.
with the stereo microscope, you can you have that depth perception. You're seeing it in stereo, so therefore you will be able to rework as if you're naturally seeing it. Whereas with a digital microscope, as was mentioned earlier, it is a 2D flat image, so you don't have that depth perception. So the first question would be, are you planning to just do purely inspection, just looking? And the second, or would you want to be doing reworking? So looking and touching.
Yeah.
That didn't come out right.
Next question.
Looking and manipulating.
Yeah.
Yes.
No, I got you. Yeah. It all makes sense. I'm
I
a
think
big
the next
believer in
question-
hands-on. I'm very tactile, so I need to actually see something
then
and
you want to
feel
see
it
in stereo.
yeah, absolutely.
Right.
Yes.
Nothing better than seeing in stereo, right? Next question would be the magnification range, because that will then determine the type of microscope, whether it be digital or stereo, because some of them have limitations in that field. Working distance, we go back to again. Field of view, again, we mentioned earlier, is a topic as well, depending on, again, how much of the sample do you need to see, or PCB do you need to see at any particular time. You might be working with PCBs with very large components, so you need to fit the whole component in.
Right.
So you need to look at that as well, especially in certain areas like aerospace, where they have big connectors, etc., on PCB boards. Again, you want to get as much of that component in at any one time. Illumination, again, whether it's not only illumination from the top, but if you're looking at through holes, so you might have to get illumination from the bottom, which is another area. So we need to determine, again, what the application is, and then we'll decide whether it's illumination from top, bottom, or both. In some instances, you might do both. And choosing the right microscope at that point will save you a lot of money moving forward, because it might mean having to change the whole stand of the microscope if you suddenly decide you need lighting from the bottom. And then the other thing which we always ask a customer is, are you looking at image capture at any stage? In other words, having to capture images or project them for teaching purposes up to a monitor, which is quite possible. So you'd be able to then use it for teaching or discussion purposes by projecting those images, whether it be a stereo microscope or a digital instrument. You can then project those up, as I said, onto monitors, or would you want to do basic dimensioning, with measurements of thickness of tracks, etc. Again, that could well be an application. So once we've got, I think asking those primary questions would give us an idea in the direction to steer the customer.
And then also, I think I would just add the actual workspace that the customer has. Where will it be used? So is it going to be used in a lab where there's plenty of room? That could determine the type of stand that the system would be placed on, or is it going to be used in the workshop where there's limited room? So that's another important question.
Very good ergonomic or logistical concern there. Yeah,
yes.
That's practical. When it comes to, Richard, you talked about magnification. One of the questions you ask is, how much magnification do you need? Is it common for someone to overstate because they really don't understand what level of magnification really is? In other words, if you ask me, what level of magnification, I don't know, 100x, but I'm going to maximum do everything at 16x. Is that sometimes overstated? Are people paying from time to time for more magnification than they would ever practically use?
It's possible, Mike, but I think generally speaking, in the electronics industry at this stage, and we have to say at this stage, because again, as we keep saying, things are getting smaller and smaller. At this stage, magnification really that is usable, and specifically if it's going to be for rework, it's exceptionally difficult to do anything above sort of 20 times or so, even if the components were small, because you can imagine just a tremor in the human hand and trying to hold a soldering iron is magnified 20 times, right? So I think that in itself gives you an indication as to where you need to be as far as magnification. But I think there might be areas where you're working with very small components, that it's just placement of components or making sure components are placed correctly. You might go to magnifications of, say, 30, 40 times. But beyond that, it's very unlikely that you'd really need to go to beyond that magnification. I'd say in the electronics industry, 60 times would be tops. And then there's the odd occasion, I have to say, in microelectronics, and I say micro, I use that term very loosely, where components are now going into medical devices where magnifications might go higher, but they're generally then just for inspection as opposed to manipulating the sample in any way at higher magnifications.
Something that I found, at trade shows when people come over, you ask them what magnification they're currently using, and they do tend to know roughly what magnification.
Yeah, microscopes aren't new technology; they've been around a long time.
Right.
So,
and the other thing is, if they're not quite sure what the magnification is or what they need, then another thing that they should look for when purchasing a microscope is whether companies do demonstrations, whether they could come on site and actually do a demo, and then they could, figure out what they really need for their application.
So what types of questions should, I just asked that. All right, we're going to wrap up. So finally, it's time to get out your crystal ball. You're now officially fortune tellers. What trends do you foresee in the future of microscopes and visual inspection tools for circuit assemblies, since that's the world we live in? Are there any emerging technologies that we should be, don't tell me anything where you'll have to kill me, but no company secrets, but are there any emerging technologies that are making their way? Clearly, as you both alluded to, electronics have been highly miniaturized over the last decade and more. And that's resulted in the need, in some cases at least, for higher magnification levels. But where do you see the trends going in optical technology? Your company clearly advanced that technology with the eyepiece-less systems that you have. What's where are we going? Where are we going as electronics will continue to evolve, continue to miniaturize, and how will your industry respond to that?
Well,
I think,
sorry,
Go
if
ahead,
I
Neely.
could just interject there
Oh,
very
sure,
quickly. Something that I will mention at this stage is I keep saying digital microscopes and everything is in 2D. Well, we have actually patented a piece of equipment, which in actual fact is two digital cameras linked with an optical zoom, and that projects an image onto a mirror, and that gives you a three-dimensional digital image. So it's a combination of digital and optical, gives you a three-dimensional image. The beauty of the system, though, is that you can actually interface with another unit anywhere else in the world using the internet, and you can then compare or review a particular sample in 3 dimensions in real time. So I could share an image that I have in Japan with you sitting in America, and you can actually view that sample together in 3D. So that is very unique, and it's unique to Vision at this stage with our patented technology.
I see a day when the eyepiece-less microscope or eyepiece-type microscopes will be replaced with vision goggles. And
yes, so virtual reality or augmented
Absolutely.
reality,
Absolutely.
that it's all around us, not just for gamers. And sure, I mean, it could come into the inspection world without a doubt, where users are able to maybe almost immerse themselves within that 3D image of a component.
But to try and do that for very long periods of time, it's very isolating. We've actually looked at this out as a company, but it is very, very isolating. And
Yeah.
there are areas in the world which use 3D goggles in the industry, but the feedback from people after using it for a long period of time is you're living in a bubble. You can't really interact with anybody. You can't go around and speak to somebody about it because you're wearing these goggles. It is.
Yeah, I've read reviews on the Apple Vision goggles, which are A, amazing, but B, heavy. You're tethered to a cable, not just a wire, a cable. And yeah, that poses safety. If you see YouTube videos all the time of people in VR games
driving vehicles,
walking into walls, right? Because they're playing this immersive video game and they're not aware of their surroundings. And but I do see a time when, and this would be no threat to the microscope manufacturers of the world, because you still have to make the optics, you still have to be able to capture an image and generate an image. Where you're broadcasting it to, whether it's through an eyepiece or eyepiece-less optical screen or a digital screen, is that's besides the point almost. But still, the quality of the image and the manipulation of the image and the illumination of the image is still all well within the microscope manufacturer's set of responsibility. That's not going to go away. Just how it's delivered to the operator will be an interesting road. We'll see.
Yes.
How far that goes, and whether the young generation will demand it. You and I will wear these things for 10 minutes, and I'm a techie kind of guy. I'm like a early adopter, and I'm an Apple fan, and every part of me wanted to buy those $4,000 goggles. I didn't, because I'm married and I'd like to stay that way. But I would have been, if I was in a different life, I would have been lining up at the store waiting to buy them. And I probably would have used them for a few days, and they would probably be a $4,000 paperweight on my bookshelf, right? Because it would get old after a while.
Yeah.
But I do see younger generations who are growing up with that tech, almost demanding something like that. Where else are we going with the future of optical inspection?
Well, the two other areas that I see where there could be growth in the future is, continuing to improve the ergonomics of systems. And, it could be that maybe in the future a microscope is developed where it's able to sense the operator's position and actually manipulate the microscope around the operator so the operator is more comfortable.
Yeah.
And another, sustainability, that's going to be big. And, it is big, it's growing. And perhaps, thinking about what are the microscopes being made out of, and how that is affecting the environment, maybe. So
yeah, I mean, a lot of companies are, particularly larger companies, have pretty strong ESG programs in place, and they're desperate to check something off a list,
Right. Sure.
And,
right.
And, to some people that might seem silly, but to others, it's important for a big company, to
Right.
get the credits, to get whatever they're looking for, whether they're really trying to make a green world or they're trying to just check boxes. Either way, it's an important factor. We'd
Sure.
be foolish to
And
ignore
a
that.
trend that is growing.
Yeah. Interesting. Well, any other final bits of wisdom for my audience when it comes to optical microscopes or digital technology for that matter? Any parting thoughts of wisdom?
Gee.
I think we've wisdomed you out.
Yes, I think we've said it all.
We have two salespeople in the room who are speechless.
Just trying to think
That's
what we didn't cover.
That's a first for the show. Well, that's great. Well,
No, I think
Richard,
we covered all the major points, and I really hope it's been useful for the audience. Choosing a microscope is important, and ergonomics is exceptionally important in the workplace, and we're seeing more and more of it. We're seeing a lot more companies that have employed ergonomists or got their health and safety people involved in ergonomics, and I think it's important. Production, it's a proven fact that if operators are in an ergonomic position and feel comfortable, productivity goes up, reduced scrap rates. So there's a lot going for ergonomics in the workplace, not only on the microscopes, benches, seating, etc. It all plays a big part to production.
so for my audience, if you'd like to get a hold of Vision Engineering or get any more technical information from them on the subject of optical microscopes and inspection technologies, their contact information will be in the show notes. Richard and Neely, thank you so much for being my guest today. Thanks for all your time. Thanks for generously imparting wisdom on the subject, educating me and hopefully my audience.
Thank you, Mike.
Thank you so much, Mike. Thanks for the invitation.
My pleasure. Well, that's another episode. Thanks for listening to or watching the Reliability Matters podcast. Don't miss an episode. Subscribe to Reliability Matters on your favorite podcast app. If you're watching this podcast on the Reliability Matters YouTube channel, be sure to click the like, subscribe, and bell icons to be notified when new episodes are released. We release new episodes on the second and fourth Tuesday of every month. And a special thanks to the Printed Circuit Engineering Association's PCB chat at pcbchat.com and Ascendo Reliability at reliability.fm for syndicating the show. Thanks also for your questions and episode suggestions. Please keep them coming. I love to hear from you. Send comments or questions or episode suggestions to Mike at mikeconrad.com. Just remember that's Conrad spelled with a K. To learn more about the Reliability Matters podcast, please visit the Reliability Matters podcast website at where? You guessed it, reliabilitymatterspodcast.com. Once again, thanks for listening or watching. Until next time, stay safe, stay healthy, stay happy, and perhaps more importantly, keep doing it right. And I'll see you again in 2 weeks.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.